Okay, good evening all. So in today's class, we'll be discussing about complex numbers, part 2, problem discussion. Okay, so today's class is focused on AI ETC 2024. In the previous class, we have discussed about complex numbers and quadratic equations, formula and concept relation. So in today's class, we will be discussing about practice problems. Okay. So in the previous upload, I have uploaded a YouTube Shorts. In the YouTube Shorts, it was purely focused on English. So English, upon analyzing many papers, we have found out that around out of 20 questions in English, around five questions are asked from word meanings, synonyms, antonyms, etc. So daily I will be giving in the form of YouTube shorts five important words along with their meanings. So go through that. That is enough to score 5 marks in English. More topics in English, we will upload more videos soon. So let us start ahead with the class. Okay, since there is no time to waste. Okay, so the first question is, if A is equal to cos theta plus I sin theta. Okay, the value of A is given cos theta plus I sin theta. Find the value of 1 plus A and by 1 minus A. Okay, here we need a note. It's related to trigonometry. When we reach trigonometry, you will see this particular formula. Okay, to solve this question, we need to use some trigonometric formula. I'm writing it down first off. Okay, so one formula is cos theta is equal to 2 cos square theta by 2 minus 1, which is equal to 1 minus 2 sine square theta by 2. Okay, the another formula is sine theta is equal to 2 sine theta by 2 cos theta by 2. Okay, these are the two important formulas we need to know in order to solve this question. So let us start ahead with the question. Okay, we have to find the value of what 1 plus a divided by 1 minus a. Right, let us substitute the values there. Okay, that is 1 plus cos theta plus I sin theta divided by 1 minus a minus cos theta minus I sin theta. Okay, here I'm going to apply the above formulas here. Okay, so let us substitute 1 plus in terms of cos theta, I'm going to give like this 2. Okay. In the numerator, I'm going to give instead of cos theta, I'm going to give us 2 cos square theta by 2 minus 1. And for denominator cos theta, we are going to give us 1 minus 2 sin square theta. Okay. So 1 plus 2 cos square theta minus 1 plus for sin theta, we can give like this 2i sin theta by 2 cos theta by 2. Okay. Divided by 1 minus what is 1 minus 1 plus 2 sine square theta by 2 minus 2i sine theta by 2 cos theta by 2. Okay, this one and this one will get cancelled. Similarly, this one and this one get cancelled. Okay, now what we have, I'm going to write it here. Okay, we have 2 cos theta by 2. I'm going to take as common, and inside the bracket we can write like this. Okay, bracket we can write like cos theta by 2 plus I'm also took 2 as common outside. Okay, since there is both 2 here, so 2 as common, cos theta by 2 also a common here. This is not cos square theta, this is cos square theta by 2, my mistake. Okay, cos theta by 2 plus what is remaining there, I sin theta by 2, right? Yes. In the denominator, let's see what is it. In the denominator also, I'm going to take as what as common we can say. We can't take cos theta by 2. We are going to take sine theta by 2. Okay, we can take 2 sine theta by 2. But I want to make a special case where I can cancel off numerator and denominator. Okay, I can cancel with the help of this. Instead of that, let's bring a negative sign over here, minus. Okay, what happens then? Then I can write like this, cos theta by 2, because negative should go to cos theta by 2. Okay, and I'm going to give here plus I sine theta by 2. I'm just giving what is same in the numerator, and we can make it look like this. Okay, in order to make it look like this, what when we open the brackets, okay, in order to make it, I need to make it minus 2I sine theta by 2 cos theta by 2. Okay, since I took negative outside, I can give a I here. I here. What happens is that I can take a I here. Okay, what happens is that we can write in when we open this, what happens is minus 2 sine theta by 2 I cos theta by 2. See, we got this. And when I open this bracket, what happens? We get 2 I square is minus 1. This negative will go plus 1. Okay, plus 1. Then we can get 2 sine square theta by 2. So when we open this bracket, eventually we get this. So we get the answer. So I'm going to cancel off this and this. Okay, what is 2 cos theta by 2 minus 2 sin theta by 2? We get like this, minus 1 by I cot theta by 2. Okay, this is one answer. Another way is also possible. That is, we got the final answer like minus 1 by I cot theta by 2. What is minus 1? It's actually I square, right? I square by I cot theta by 2, which is equal to what? I cot theta by 2. So this is the final answer actually. Okay. So this is a simple question, guys. Just go through the formulas that I have used and just use some common sense here. We need to eventually cancel out this or it will be more complicated. So just I apply that, and in order to get the what we have got here, I just substituted. That's it. Okay, let us move on to the next question because this question is a very easy question. Okay, next question. Okay, so here if 1 plus I of z equal to 1 minus I of z bar, we need to show that. So instead of ATC exams, they will ask us to find the value of z or z bar. Okay, that's why I'm particularly doing this question. Okay, this question has been asked in CBSE board for hundreds of years. Okay, so we can write like this. We have what? Let us write down the given data. 1 plus I of z is equal to 1 minus I of z bar. Okay, what is z by z bar? Z by z bar is equal to 1 minus I by 1 plus I. Whenever we get like this, what we do, we take the conjugate and multiply numerator and denominator, right? So do like this, 1 minus I divided by 1 minus I is equal to 1 minus I the whole square divided by 1 plus I square is 1 plus 1. So 1 minus 2I plus I square is minus 1 minus 1 divided by 2. Okay, so this and this get cancelled. Minus 2I by 2 is minus I. Okay, minus I. So we get z by z bar is equal to minus I. So what is z? Z is equal to minus I z bar. Hence proved. Hence proved. Okay. They might ask the value of z in 86 exams or z bar in 86 exams. Okay, here what is z bar? Z bar is equal to minus I by z. Okay, that's also one of the results. Okay, let us go to the next question instead of wasting more time. Okay, okay, interesting question. It's actually quite tricky, but it's very easy. Okay, what is the given data? If argument of z minus 1 is equal to argument of z plus 3i, then find what we have to find x minus 1 is to y. Okay, okay. So we have in the question which is given that z is equal to x plus iy. Even when z is not given, we can take z is equal to x plus iy. Okay. So what is the given data as per the question? That is argument of z minus 1 equal to argument of z plus 3i. Okay, that is what is z? We can write like this, argument of x plus iy minus 1 equal to argument of x plus I of y plus 3, right? Because I is common for both. Okay, so what is argument of x plus iy? Argument of x plus iy, what is it? It is actually represented by theta, which is equal to tan inverse y by x, right? So in here, what is this theta? Theta is equal to tan inverse y by x minus 1, right? This is equal to, in this case, what is tan inverse? Tan inverse y plus 3 by x. Okay, let's cancel this cancelled out. Okay, we get what is it? xy is equal to x minus 1 into y plus 3, right? Okay, so I'm going to continue here at this like this. Xy is equal to xy plus 3x minus 3y plus 3. Okay, xy we can cancel out. So we can write like this. We can write like this 3x like this xy plus 3x minus y plus 3 xy. Okay, sorry. Let's go to the next page. We don't have that space here. So when we expand, we are getting like this. That is, sorry, we're getting like this. What we are going to expand? Xy is equal to x minus 1 into y plus 3, right? Let us just expand. Xy is equal to xy plus 3x minus y plus 3. Okay, we can cancel off this. Okay, so 3x plus 3. No, it's not plus 3. Minus 1 into plus 3 is this is minus 3. So minus 3. So 3x minus 3 equal to y, right? That is 3 into x minus 1 equal to y, right? So we can write like x minus 1 by y equal to 1 by 3. So the answer is x minus 1 is to y equal to 1 is to 3. So this is the answer. Okay. This was a simple question, guys. Just apply some formulas and understand the concepts. Let us go on to the next question. Okay, this is also prove that question which can be asked in exam in the form of what is Z1 or what is Z2, like that. Okay, let us do it. Okay, so many students were asking whether it is possible to solve every question by 1 minute. So in this video, you can clearly see that even in this blackboard, I'm solving the questions very fast so that I can myself prove that we can solve the questions within 30 seconds to 1 minute, depending on our speed. So keep on watching these videos daily because what I'm teaching here, sometimes the same questions can be asked in ATC exams. Okay. Okay, so here Z1 and Z2 are two complex numbers such that mod Z1 is equal to mod Z2 and argument of Z1 plus argument of Z2 is equal to pi. We have to show that Z1 is equal to minus Z2. That is just assume that we need to find the value of Z1 as per ATC question paper. Okay, so here I'm going to define two complex numbers Z1 and Z2. In terms of these, whenever like modulus and argument are given, we can't take Z1 is equal to x plus I. That is which makes us very difficult to calculate. At those type of questions, we always have to take Z1 as R1 cos theta 1 plus I sin theta 1 and Z2 as R2 cos theta 2 plus I sin theta 2. Okay, and also what are the given things? We are given that mod Z1 is equal to mod Z2. Okay, which means that what implies what is mod Z1 mod that is amplitude, that R1 equal to R. That is what it means because root what sin square theta plus cos square theta, it is 1, right? Root of cos square theta 1 plus sin square theta 1, 1. The second one will also become 1. So eventually we get R1 equal to R. Okay, we can mark that as equation number 1. Equation number 1. Okay, and what is the next thing? Next data we are given argument of Z1, argument of Z1 plus argument of Z2 equal to pi. We know that what is argument of Z? Argument of Z is equal to theta. So eventually what is argument of Z1? We can represent as theta 1. What is argument of Z2? Eventually it will be theta 2. Okay, what is given the question? Theta 1 plus theta 2 is equal to pi. So theta 1 we can write as pi minus theta 2. Okay, this is a given question. Okay, so now let us take the first thing. What we need to find? We need to find the value of Z1. So let us start from Z1. Okay, I'll start from here. Okay, Z1. What is Z1? What we have defined it as R1 cos theta 1 plus I sin theta 1. Okay, so Z1 can again be written as what is R1? R1 is, I have proved by equation number 1, R1 is R2. Okay, theta 1. In terms of theta 1, I can write like this. Cos of pi minus, it is theta 1 here. I sine theta 1. Cos of pi minus theta 1 plus I sine of pi minus theta 1. Okay. Okay. After that, next page. Okay, Z1. Z1 is equal to, we can write like this. What is cos of pi minus theta? Not, sorry, it's not pi minus theta 1. It is, here it is pi minus theta 2. See this equation. Equation 2, pi minus theta 2 plus I sine of pi minus theta 2. Okay. Z1 is equal to R2. What is cos of pi minus theta 1? Sorry, pi minus theta minus cos theta 2 minus cos theta 2 plus sine of, because we know that, so this is 0, this is pi by 2, this is pi minus something. Here sine can only be positive, so eventually cos will be negative. Okay, so sine of pi minus theta 2 will be positive, so there is no problem there. We can write like this, I sine theta 2. Okay, after that we can eventually write like this. Okay, we can write like this. Z1 is equal to minus R2 of cos theta 2 minus I sine theta 2. Right? Now we've eventually got the answer. Okay, that is Z1 is equal to minus Z2 bar. Because we know that Z2 is what? R2 into cos theta 2 plus I sine theta 2. What is Z2 bar? Changing the sign of the imaginary term. Z2 bar will eventually be equal to R2 into cos theta 2 minus I sine theta 2. Isn't that what we got? So we got the answer. Simple. So this is the answer. Okay, let's go on to the next question. Okay, if Z1, Z2 are 2 and Z3, Z4 are two pairs of conjugate complex numbers, then find argument of Z1 by Z4 plus argument of Z2 by Z3. Okay, it's a tricky question, but if you know the concept, we can apply it simple. Okay, so here in terms of these type of questions, argument, amplitude are given, we always need to take Z is equal to R of cos theta plus I sin theta. Okay, I have mentioned in the previous problem also. Okay, so the conjugate of Z will be Z bar is equal to R into cos theta minus I sin theta. Okay, here in order to find the argument of Z1 by Z4 plus argument of Z2 by Z3, we have to use the property of argument of Z1 by Z2 is equal to argument of Z1 minus argument of Z2. Okay, so let's start with Z1. Okay, so it is given that what Z1 is equal to, we can take the given condition R1 cos theta 1 minus I sin theta 1. Okay, it is mentioned in the question that Z1 and Z2 are two pairs of conjugate complex numbers. So if Z1 is equal to like this, eventually Z2 will be the conjugate of Z1. That is what is mentioned in the question. It will be like this, R1 of cos theta 1 plus, it is 1, plus I sin theta 1. I sin theta 1. Okay, cos theta 1 plus I sin. Sorry, a mistake. Z1 is equal to R1 into cos theta 1 plus, it is plus here, so it will be minus here. Okay, minus here. So in order to find the argument of Z1 argument, we have argument of Z1. What will be the argument of Z1 in this case? Argument, sorry, just a small correction. We can do some small erasing. Everyone, please listen carefully. Okay, these questions are very important. Asked in many ATC exams. Okay. So here it's, since it's plus, we have taken r into cos theta plus I sin theta, so it will be eventually minus here. Okay, so what is argument of z1 after this equation we wrote? Argument of z1 will be theta 1. Okay, here what will be argument of z2? Okay, what will be argument of z2? It will be like minus theta 1. How it came, I will show you. We can write like this, that is z2 is equal to r1 of cos of minus theta 1 plus I sine of minus theta 1, because we have to write the form of z is equal to r into cos theta plus I sine theta to find argument of z. That's why I wrote in this form. So here we can deduce that argument of z2 is equal to minus theta 1. Okay, now let us write z3. Okay, z3. So z3 we can take r2 and theta 2 terms. Okay, so for z3, okay, z3 we can write like this, r2 into cos theta 2 plus I sin theta 2. Okay, from this we can write its argument of z implies argument of z3, it is equal to theta 2. Okay, what is z4? Z4 will be same as what z3 bar, which is equal to r2 of cos theta 2 minus I sin theta 2, which will same concept we followed there. So similarly we can write like argument of z4 equal to minus theta 2. Okay, so what is given in the question? We have to find argument of z1 by z4 plus argument of z2 by z3. Okay, which is equal to, from here we can write argument of z1 minus argument of z4 plus argument of z2 minus argument of z3. Okay, what is argument of z1? Theta 1, right? What's minus argument of z4 is minus theta 2. Okay, plus argument of z2, it is minus theta 1. Okay, minus argument of z3 theta 2. Okay, this will be plus here, so this and this cancel, this and this cancel, so the final answer will be 0. But no one will expect the 0, they will expect as a very huge answer. Please be aware of all the circumstances. Okay, let's go to the next question. Okay, so this was proved to be a tricky question. Some might feel difficult, but as you go keeping on doing many problems, you will feel used to it. Okay, okay, next question. It's an interesting question. The complex number z which satisfies the condition. What is the condition? I mod of I plus z by I minus z equal to 1. Okay, so let's take z is equal to x plus iy. Z is equal to x plus iy. Okay, so we can write like this, x plus iy plus I divided by minus x minus I of y minus 1 equal to 1. That is, I just separated the imaginary terms and real terms. Here also I can do like this. You can give like this, y plus 1, I of y plus 1. Okay. After that, so when we take root of the whole root of x square plus y plus 1 the whole square divided by x square plus y minus 1 the whole square equal to 1. I'm putting the root in the RHS, it will become 1 square. So eventually we will get like this, x square plus y plus 1 the whole square equal to x square plus y minus 1 the whole square. We can cancel out these two. So y plus 1 the whole square minus y minus 1 the whole square equals 0. If you know the identity, we know the result is 4y equal to 0 implies y equal to 0. Since y equal to 0, we can say that the complex number z lies on real axis, because the imaginary part is 0. So eventually we can say z lies on real axis. Real axis. Okay, so a real axis, that is x-axis. X-axis, B is the answer. Okay, let's go on to the next question. Okay, what is the next question? Next question is given as f of z is equal to 7 minus z. F of z is given as 7 minus z by 1 minus z square. Z is equal to 1 plus 2i. We have to find mode of f of z. It's simple. First of all, we just find mode z. What is mode z? Because why I am finding mode z, look at the options. Options is given the form of mode z. So if we try to find mode z the last minute, we are wasting time. Root of 1 plus 4 is root 5. Okay, we have root 5. Okay, now first of all, let's find out f of z. Okay, f of z is equal to 7 minus z by 1 minus z square. Let's substitute the value of z. That is 7 minus 1 minus 2i divided by 1 minus 1 plus 2i the whole square. Okay, after subtracting the values, we'll get like this. 7 minus 1 is 6. 6 minus 2i divided by 1 minus 1 minus 4i square minus 4i. Okay, so after further substitutions, we'll get like this. 6 minus 2i divided by 4 minus 4i. Taking 2 common outside, we'll get like 3 minus I by 2 minus 2i. 2 minus 2i. Let's take the conjugate and multiply. That is 2 plus 2i from here, and also 2 plus 2i from here. After that, we'll get like this. We'll get like 6 minus 2i plus 6i minus 2i square divided by 4 minus 4i square. Okay, which is again equal to 6 plus 4i plus 2 divided by 4 plus 4. Okay, which is again, after substitution, we will get like this. 8 plus 4i divided by 8. We will get like this. That is 1 plus 1 by 2i. Okay, that is our f of z. F of z. Then what is mode of f of z? Mode of f of z equal to like this. Root of 1 plus 1 by 4 equal to root of 5 by 4 is equal to root 5 by 2. What is root 5 by 2? Mod z by 2. Mod z by 2. So what is the answer? Answer is actually a mod z by 2. Okay, it's a simple question. That's why I did it in one page. Let's go to the next question. It's a simple question, right, guys? So complex numbers, we can expect minimum of 2 questions to a maximum of 4 questions. Let's move this question for the last time. Okay, last. Let's do this question. It's an easy question. Okay, that question, the previous question is somewhat important, asked in many HSC exams. Okay, so write an entrance point first of all. If two complex numbers z1 is equal to x1 plus I by 1 and z2 is equal to x2 plus I by 2 are equal, then mod z1 equal to mod z2 equal to root of x1 square plus y1 square equal to root of x2 square plus y2 square. Okay, so in this question, similar cases given. That is, two complex numbers are equal. That is, a plus ib equal to c plus id. That is given, a plus ib is equal to c plus id. Let's take modulus on both sides. Mod of a plus b is equal to mod of c plus id, which is equal to root of a square plus b square is equal to root of c square plus d square. Okay, squaring both sides, what we get? A square plus b square equal to c square plus d square. Isn't that given the options? Yes, option D. Okay, let's move on to the next question. Yes. Okay, this is also important question. This question was asked in many exams. RRB exam, it was asked. It was asked in JE Advanced, JE Mains, and also air traffic control, AITC exams. Okay, So this question is a sure question for this exam. Okay. So what we have to do first? We have to equate with the help of the conjugate. That is 1 plus I by 1 minus I into 1 plus I divided by 1 plus I. That is equal to, we get like 1 plus I the whole square divided by 1 minus 1 plus 1, 2. Right, 2. That is the whole of x, the whole raised to x. Okay. That is, let's expand this. That is 1 plus 2I plus I square divided by 2. I just computed this very fast. Okay, that's it. The whole raised to x equal to 1. Okay, that is I square is minus 1, right? This is minus 1, so this and this I can cancel it out. So 2I by 2, the whole raised to x, the whole raised to x equal to 1. Okay, so 2 cancel, I raised to x equal to 1. When, in which case I raised to any power is equal to 1, I raised to 4 equal to 1. Is there any option like that? That is x is equal to 4. I raised to 4 or a multiple, that is here x can be 4 or a multiple of 4 or 4, and where n is belongs to natural numbers. Okay, so the value answer is B. Okay, answer is B. Okay, okay, so let's go to the last question. Yes, this is an important question, guys. Please listen carefully. Okay, so if Z is a complex number, then okay, here it's mentioned that it's not mentioned in amplitude argument. So in this case, we can take Z is equal to x plus iy. Z is equal to x plus iy. Okay, so what we have to check? So we have to first of all find mod z and then find mod z the whole square. Then we can go ahead with finding z square and its mod of z square. That's enough. So what we have to find first? First we have to find mod z. What is mod z? Mod z is equal to x plus iy, which is equal to root of x square plus y square. Okay, so what is mod z square? Is equal to x square plus y square. Okay, now what is z square? Z square. Z square is x plus iy the whole square. This is equal to what? X square plus I square y square plus 2xyi. Okay, which is equal to what? This is equal to x square minus y square plus 2xiy. Right? Okay, so what is mod z square? Mod z square equal to root of x square minus y square the whole square plus 2xy the whole square. Right? Let's expand the brackets inside power. Okay, that is x raised to 4 minus y raised to 4 plus 2x square y square plus x raised to 4 plus y raised to 4 plus y raised to 4 minus 2x square y square plus 2x square y square. Right? We can cancel off these two. Okay, this is equal to what? Root of, sorry, it's not 2, it's 4 here. Okay, it's 4 here. What is 4 minus 2? It's 2. So we'll get like this. Root of x raised to 4 plus y raised to 4 plus 2x square y square. Isn't that the same as root of x square plus y square the whole square? So it's just equal to x square plus y square. So what is x square plus y square? It's equal to mod z the whole square. So therefore we can say that mod z square is equal to mod z the whole square. Okay, so do you have any answer like that? Yes, B, option B. So now we have did many questions related to complex numbers and quadratic equations. So in the next class we'll be focusing on physics. So hope all of you understood the class. Please go through this question. These questions are enough for ETC preparation. So thank you all. Have a nice day.